Okay, so I'm going to be providing short videos to review important concepts that you're supposed to be looking at pre-class. I do want to emphasize that these videos are definitely not designed to take the place of reading the chapter or doing the guided exercises. That is definitely still going to be a major source of your learning during these pre-class times. But I do want to provide sort of different modalities for you to hear, being exposed to the information, and even sort of chance to see some examples work through, because they can tend to be helpful. Now, these videos are not particularly helpful to you. They're not required viewing by any means. These are designed just sort of give you multiple avenues to sort of explore the material. We are doing the data display chapter for this week, and there are 4 primary learning outcomes that your goal is to try to get a handle on before coming into class. That is to be able to define the basic concepts of data, types of variables and types of measurements, to construct a basic frequency table using both grouped and ungrouped data. You should be able to sketch a histogram based on those frequency tables for both grouped and ungrouped data. And you should be able to have some basic ideas about what a histogram is and what it looks like. You should be able to describe its shape, predominantly based on its peaks, its skew, and its kurtosis. Those are all 4 things that you can find in the textbook, and you should be taking a look at them. But we're going to go ahead and kind of review real quick all 4 of those now. So the first one is defining basic concepts of data, types of variables, types of measurements. This is terminology we're going to be using in the class. The idea is when you're looking at an experiment, when you're looking at a research proposal, there's a few things we need to zero in on, look at. The first thing is the important idea of a variable. Variables are characteristics, things that can have different values. There are multiple kinds of variables you'll run into in research. You have those things that we are purposely manipulating and changing, such as the amount of a drug we're giving, such as the study technique that we're promoting, such as a social manipulation we're using. These are things we're intentionally changing. These are often called our independent variables. There are those variables that we are interested in measuring to see the effect of the independent variable. These are going to be things that can have different values, hopefully dependent upon our independent variable. So the independent variable are things we manipulate, dependent variables are things that we measure, and then there's a whole lot of other things that can change that are usually problematic, things that we don't want changing, things that will just confuse our results. It's very difficult to keep everything the same between all of our subjects, and that's what we call confounding variables or nuisance variables, things that can come in and change and can affect our data in ways that we don't have control over and can actually cause substantial problems for the accuracy of our analysis. In statistics, the main variables we're going to be usually focused on are our dependent measures. We're going to be looking at those things we measured, and we're going to be asking questions about what that measured data looks like. Most data is going to have what we call values and a score. This is one area where it can be a little confusing, because sometimes when we use the term value, we think of it as what value that variable contains, and that's partially true, but in statistics, value has a very specific definition. A value is the range of possible outcomes or categories that a given score can have. So if you have something like a Likert scale, where you're like, on a scale of 0 to 5, how much do you like this thing? 0 being not at all, 5 being a lot. Right? That means that our values are 0, 1, 2, 3, 4, and 5. Right? We could have something like the colors of the rainbow. Right? Our values then for the color of the rainbow, like what is your favorite color of the rainbow? Our values then are going to be the red, orange, green, indigo, violet, and blue. Right? Those are our values. Or they can be, things like temperature, which can have an infinite range in the negative to the positive, depending on what we're measuring. So a value, it can encompass a lot of different metrics, but the value is the range of possible scores. And then the score is the particular value of a variable, usually for a single subject or whatever we're measuring. All right, so a subject is going to have a score for their variable. Their variable is going to have a score. That is their individual score, and that score is going to fall within a range of values. We also have to talk about the kinds of variables that we can be measuring. We have things like the color of the rainbow, right? I just talked about. Those are things that are categories, right? They're not numbers. I can't ask somebody their favorite color, and somebody says green and somebody says red, and I ask, well, what's the average of green and red, right? It doesn't make sense. And what's your favorite car? What's your favorite television show? These are things that are sort of non-numerical. They're what we call nominal variables. That's opposed to something like an ordinal variable, which is a rank, right? Like if I wanted to rank students in a class, first, second, third, fourth, fifth, sixth. One of the big things about ordinal variables, while there's some numerical relationship between them, there is no set scale. So the difference between first and second is not necessarily the same as the difference between second and third. Interval is numerical data where there is a set difference between them, but they don't have a 0 point. Whereas ratio is where we have a strong 0 point. The last thing to think about is whether something is discrete or continuous. For example, if you ask how many kids somebody has, they're going to have 1, 2, 3, 4, 5 kids, whatever it is. They're not going to have 1.5 or 1.74 kids, right? The average number of kids in households in the United States can have that decimal, right? But any individual family isn't going to have 1.37 kids, right? So that's what we call a discrete variable, that there are individual values, as opposed to something that is continuous, which means it can be any number, an infinite number between any two given points. So again, something like temperature, can make a good continuous variable. Reaction time can make a good continuous variable, right? The volume of a drink, any of these things can range. So, between 1 to 2 liters, you could have 1.3756 liters, no problem, right? So those are the primary terms you should be thinking about for that first outcome. Okay, let's look at frequency charts and histograms real quick. So here's a chunk of data. This is some data that looks at average amount of screen time during self-reported screen time during the pandemic, time spent on cell phones, laptops, computers, etc. So this is a subset of the data, and we could be asked, okay, how can I present this data? The first thing in a frequency chart is to reorganize the data in terms of its possible values in its order from least to greatest, right? So our actual possible values here, if we look at our values, looks like they range from about 2 to 10. So it looks like hour units, right? So, you could probably have 0 hours of time. So let's do 0 to 10 as our frequency. So we'd have 0. This is 1, 2, and I'll meet you when I'm done doing this. All right, so we have our 0 to 10 hours organized in order from least to greatest. And now we have to count the number of times we see those numbers frequency. So there are no 0 hours. There are no 1 hours. How many 2 hours do we have? We have 1, 2, 3, and 4 2 hours. How many 3 hours do we have? Looks like we have 0 3 hours. How many 4 hours do we have? 1, 2, 3, 4. So we have 4 of those. How many 5 hours do we have? 1, 2, 5 hours. How many 6 hours? We have 1 6 hour. How many 7 hours do we have? We have 1, 2, 3, 7 hours. How many 8 hours do we have? Looks like we have 0. How many 9 hours do we have? Looks like we have 0. And how many 10 hours do we have? It looks like we have 1. All right, so always do a sanity check anytime you've done your frequency table, right? How many data points do we have? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So we should have 15 in the frequency. We have 4, 8, 10, 11, 14, 15. That's a good just sanity check to make sure that we've captured everything. All right, so this is our frequency chart. We now know for each value the number of times a score appears. We can also do something called grouping or binning our values. So we can actually create a range. So you can decide your bin sizes, but let's do something dramatic just for fun. We'll do like 0 to 5 hours, and then we'll do 6 to 10 hours. All right, so how much of our data falls between 0 to 5 hours? Well, we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, so we should get 5 here, so it's going to be 1, 2, 3, 4, 5 for our larger bin. And you can do as many bin sizes as you want. That's a frequency table. Hopefully pretty straightforward. To do a histogram, right, we can look at just, right, so we come over here, and so we draw our axes, right? So our x-axis is going to contain the time. I'm drawing with a mouse, so I apologize that it's not super clean, right? And then our y-axis is going to be frequency, all right? And time is going to be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, and our frequency is going to go up to 1, 2, 3, 4, and 5. All right, so let's draw it out. So 0, we have 0, right? 1, we have 0. 2 starts us off at 4. 3, we have 0. 4, we have 4. 5, we have 2. 6, we have 1. 7, we have 3. 8, we have 0. 9, we have 0. 10, we have 1. All right, so that's our basic histogram. Describing a histogram involves looking at its shape, its skew, its kurtosis. You're going to want to make sure you're looking up those terms and looking at examples. We can draw a distribution that kind of covers our data points. It's not perfect. Generally speaking, what we're looking for is looking for a number of peaks. I would argue that this is probably a single peak, though if you wanted to argue that we really do go down to 0 at each of these, right? Perhaps it's 3 peaks or even 2 peaks. What I'm looking for is justification on those shapes. There's definitely a positive skew. Our data is skewing out here to the positive, and the kurtosis, which is the spread of the data, is fairly wide. All right, and then we can do the same thing for our grouped data, which have a frequency chart, right? So our time is down here. Our frequency is over here. But now we're going to have the 0 to 5 and the 6 to 10, right? And we're going to have like 0 up here, 10 up here. So our 0 to 5, right, is going to be way up here. And our 6 to 10 is going to be about half of that, right? So these are real rough sketches. Drawing with a mouse I'm not very good at. But that's the idea. So that's how you form your frequency table. That's how you form your histograms. You should be taking a look at the chapter and working through your guided exercises. And I will see you in class.